P5. Solving equations graphically, numerically, and algebraically. So to start with, solve the equation graphically by finding the, nope, I lied, we're not starting there. Solve the equation by extracting square roots. I was looking at the wrong problem. Number 8, 2 times x minus 5 squared is equal to 17. Crooked. Okay. All right, so we divide by 2 first. So x minus 5 squared is equal to 17 over 2. Then we'll take the square root of both sides. So x minus 5 is equal to, don't forget, when we're solving, it's going to be plus or minus the square root of 17 over 2. And then add the 5 over. X is equal to 5 plus or minus the square root of 17 over 2. If you leave it like that, that's fine. We technically should get rid of the radical on the bottom here. So by multiplying that by the square root of 2 over square root of 2, this would give us x is equal to 5 plus or minus the square root of 34, right? Yeah, over 2 would be the technical correct answer for this. The book made it a decimal and did it that way instead, so. Now, with this one, well, we technically should write them separate as x plus root 34 over 2, and then 5 minus root 34 over 2. I'm okay with you just leaving it together. But if it will give you 2 distinct separate answers, like if this had been a perfect square or something, then you should get down what they both should be. Don't just like leave it randomly in a radical. So 12 in parentheses 2x plus 3 squared is equal to 169. So if I take the square root of both sides, 2x plus 3 is equal to plus or minus the square root of 169, which is 13. So here, because this was a perfect square, I do need to divide it now because it's going to give me 2 separate distinct answers. So 2x plus 13 is equal to, or sorry, plus 3 is equal to 13. Or 2x plus 3 is equal to negative 13. So 2x is equal to 10, x is equal to 5, or 2x is equal to negative 16, x is equal to negative 8. So if they're going to have the 2 separate distinct answers, split them. If not, you can just leave them. All right, solve the equation by completing the square. I know this is everyone's favorite. Oh, should have everything all out of order on my paper. All right, 14. X squared plus 5x minus 9 is equal to 0. So we're looking to fill this area here, so we need to move this 9 over. So we will have x squared plus 5x plus, I'm going to go ahead and put my box there, is equal to 9 plus box. So remember, when we complete the square, whatever we do to one side, we still have to do to the other. So we're adding a box to both sides. Anybody remember what the catchphrase is for the box?
Half the middle term squared.
Yep, half the middle term squared. So, half of 5 and then squared. So I would say in the left side, write it that way because you're trying to get a perfect square trinomial on the left. On the other side, you can go ahead and actually multiply it through. So that's going to be 25 over 4. So now on this side, I've got x plus 5 over 2 and the whole thing squared, because that's what completing the square does. It allows me to get that perfect square trinomial, is equal to, over here, if I wanted to rewrite this 9 as something over 4, it would be 36 over 4, so that I can add it together. Just trying to make life easier. So then that's going to be, what, 61 over 4. Are we following still? Okay. So then I can take the square root of both sides. So that's going to give me x plus 5 over 2 equals plus or minus, and I'm going to go ahead and split it into two separate square roots. So the square root of 61 over the square root of 4. And we already know the square root of 4 is 2, so I'm going to go ahead and subtract this. So negative 5 over 2 plus or minus the square root of 61 over 2. And it's fine to leave it like that. Since they have the same denominator, you can combine them. So you can leave it like that, or you can write it as x is equal to negative 5 plus the square root of 61 all over, or I should say plus or minus, all over 2. So same thing either way. I don't know. Book doesn't show me right here which way they write it, so just pick your favorite. All right, I'm going to do 18 with you because I'm giving you 17 as a homework assignment, so I want to make sure we know how to do it. 3x squared minus 6x minus 7 equals x squared plus 3x minus x times x plus 1 plus 3. Now, one thing I want to point out or remind you of is that in order to do completing the square, there can't be anything in front of my x squared term other than a 1. Okay, so if there's anything else, we just say we can't do it. Any ideas where I should start?
Distribute the x. With that, would we distribute it as a negative x?
Yes, I would go ahead and do that. So 3x squared minus 6x minus 7 is equal to x squared plus 3x minus x squared minus x, then plus 3. Combine like terms, 3x squared minus 6x minus 7 equals, x squareds are going away, 2x plus 3. So then I would move my numbers to the right and my letters to the left so that I can go ahead and be set up. It's 3x squared minus 8x plus box is equal to 10 plus box. Now, what do you notice about this problem?
There's a 3 in the x.
There's a 3 in front of the x squared, so as much as I wanted to show you this problem, I don't think I'm going to be able to. Let me check. But basically, the problem that I'm giving you, you can do it. All you would do is just proceed like we did. You'd half the middle term and square it and keep going in the problem that you would have. If I can ever get there. I hate this book doesn't put all the answers in the front. It's really annoying. What is this, P5? Number 18. Yeah, they got an answer, but not by completing the square. So, which is what you're supposed to do, and we can't do it. So, either there's a typo or they did some other method. So, basically, we can't complete the square here, so we would have to stop. But as far as I can tell, I think I actually have that one already worked out. Yes, yours you will be able to.
So if there's like a number of x squared, like we can't divide it, like if it's there then we just can't do it, or can you divide everything by 3, or does it not?
Actually, technically you can, which my guess is probably what they did to go about getting the problem. I would not have you do that.
Okay.
So yeah, that probably would work actually. I forget this book does stuff like that. So if we divided everything by 3, we probably could keep going, but that's going to be some really weird numbers. So I won't give you one that's that weird for you to do, because there's other methods that are way better to do that. I would quadratic formula or something else rather than that. That would be more effective and more worthy of my time. So yeah, so we'll just put a halt on that one. All right, I'm gonna jump down to 20. 20 is the quadratic formula. So 2x squared minus 3x plus 1 equals 0. So then, just as a refresher, negative b plus or minus square root b squared minus 4ac all over 2a. So I'm going to have negative times negative, so it's going to be positive. So 3 plus or minus the square root of negative 3 squared is going to be 9 minus 4 times 2 times 1 all over 2 times 2. So 3 plus or minus, let's see, what is that? 9 minus 8. So just 1. So I'm just going to over 4. And so again, because this is going to be something distinct, I want to write it separately. So 3 plus 1 over 4 or 3 minus 1 over 4. So basically I got 1, or I have 1/2 for that. Are we okay on quadratic formula? All right, so I am going to jump back. I should have just started with this, but sometimes I don't get it all in one day, so I usually go back to the graphing ones. But I am going to jump back to the graphing, so you're going to need your calculators for this one. So x squared minus 8x equals negative 15. So basically, we're going to get this all on one side, and we're going to put it in our calculator to graph it. Was it this class? Well, I know Josh is going to, but was it this class that we did like a stat plot the other day?
Yeah.
Okay, you're gonna need to go make sure that those are turned off. So under your second stat plot, there's a button that says list off or all list off or something like that. You need to make sure that they're off. Otherwise, your calculator's gonna do weird things.
How do I get to that?
Hit second y equals, which will bring up stat plot, and then it should be option like 4 or 5 that says list off or something like that. So then you're going to plug into your y equals. You'll plug in that x squared minus 8x plus 15. Now with this one, you actually could factor it. And so you could do it by hand, or you could check it by hand if you forgot how to do it on the calculator. But when you plug it in your calculator, you're going to then hit second and then the trace button. So it'll be the 4th gray button from the left.
What are we plugging into?
Y equals. Yeah. Just not the equal 0 part, just the x squared minus 8x plus 15. Oh, and because you're probably still in Zoom Stat, you're going to need to go to Zoom 6 for Zoom Standard when you graph it. Let everybody catch up before I...
I lost my X. I can't find anything.
What are you going
X is
for?
under mode at the top left. It's the variable button.
Do I put the equals? Oh wait, do I write the first equation or the one that's equal to 0?
The one that's equal to 0.
Do we put the equal to 0 or?
No.
Okay.
Oh. And then Zoom 6.
Mm-hmm. That'll be Zoom Standard to actually graph it. And we will do one more of these so you're familiar with it.
I'm gonna need to practice.
Do you want us to draw the graph?
No.
Wait, why is yours on that side?
Mine is right.
Wait, what did I do?
I don't know what you did.
You might have
Virginia.
typed in minus 15
What did you do?
because it'll shift it the wrong direction if you do.
I don't know how I got here, but I know mine is right.
Should have x squared minus 8x plus 15.
Oh, I didn't. That's
That'll also do it.
Wow, baby. Just wow.
All right, so our graph, everyone's looks like this.
Yes.
Okay, good. All right, so now you're gonna hit second and then this trace button here. And we're looking for the one that says 0. So that's option 2. Then it's gonna ask you to find my thingy. Where is it? Hello? Oh, there it is. All right, so you want, see this is flashing, okay? You want it to be on the left side of my first intersection, which is gonna be right here. So anywhere on this side, I could have left it like way up in Guam where I couldn't even see it. Hit enter. Then it's gonna ask for a right bound. So then it wants you to go to the right. So you just need to go down below the x-axis So, and it doesn't matter if you're one below or you're way over here, doesn't matter. Once you get there, you're going to hit enter. Now, until it'll ask you if you want it to guess, and until you say enter again, it's not going to do it for you. Once you do that, it tells you that there's a 0 at x equals 3. So one of your zeros is at x equals 3.
How'd you get the left bound? Like, how'd you know where to put the little flash thingy?
So it's just going anywhere on the left side of my graph above the x-axis, basically.
Okay, so it doesn't really matter where.
Yeah, but so in a second it's going to be different because when I do this one over here, so right now I found this one. Well, when I go to do this one in a second to get my other 0, the left bound is going to be down here and the right bound is going to be up here.
Okay.
So it's just always to the left of the axis where it's crossing is basically, and then to the right of the axis where it's crossing. So we can do it again. Second trace, 0. So now my left bound is going to be somewhere down in here. Okay, somewhere below the axis. It's on the left side of this point. Then the right side, I just need to go up over the axis. Okay, on the right hand side. Let it guess again. And my other 0 is at 5.
So we just click, like we can do it anywhere on each side.
Yeah, so you could go up to Timbuktu or whatever.
And
we're
it'll
supposed
come out
to-
the same thing.
As long as you have it so that it is basically the point where it's crossing, so where this is currently flashing, has to be in the area. So if you said that your right bound one was down here and your left bound is up here, it's going to get confused. It's going to be like, huh? So it's got to be left to right when you're reading it, but it kind of just like follows it down. So it's like left to right / up to down. Or in some cases, I guess, down to up when you get to the other one. So, and this is just, this is just supposed to be a tool to help you. Obviously, this one we could have factored into x plus 5 or x minus 5, x minus 3, and we would have gotten the same thing. But like the next one, you wouldn't be able to factor it. So, like with this one, x times 3x plus 11 equals 20. Now, before we start, you can go ahead and write this as 3x squared plus 11x minus 20. And you can type this in. The other option, you could actually into your y equals do this. And as long as you have that parentheses on there, it'll graph it the same way. I would probably tend to, just because what I'm used to, is to do it this way. But you don't necessarily have to.
We did the same thing we did before.
Yeah. So I'll just put it in again.
Do we press second before we press trace? Or do we just press trace?
Second. Because we're going for the calc function, which is
That's
above
very
it.
long.
Yeah. Trace, technically speaking, would get you there. But it would probably be really irritating. Because you'd be arrowing till it's exactly y equals 0. So that you get your x value. So this one, again, I don't need to see the whole graph. I don't care about the whole graph. I only care about where it crosses. So when you do your 0, where is it? Hello.
It's coming.
Oh, it's right there. Okay. Hold on. Come on, buddy. There we go. Welcome. All right. So, I just sound like an absolute idiot on a recording, but it's fine. All right. So, anywhere up there is fine. Anywhere down here is fine. Guess. So, I have a 0 at x equals -5. And do my other one. Okay, there we go. So left bound, right bound. And so then my other one is that x is equal to 1.3 repeating.
See, I always get the second one you get first. Like, I don't
It doesn't matter which one you get first.
Okay.
It's just you're just doing this side before this side
That's what.
is all. It doesn't matter what order you do them in as long as you have them both.
Okay.
It's like when we factor, you could have had the x minus 5 before the x minus 3 on the previous one.
So now that I've found the first one, so like that was my first one, what do I do after that?
So you'll have to hit second trace again.
Okay.
You basically go through the whole process twice.
Got it.
So I just basically, when you said, oh, it's still coming or whatever, when I couldn't find the cursor, it was already set to do the one on the right. I could have gone ahead and done that one first. I just have this thing about doing the one on the left first.
And when I do this second one, I put it in a different spot than I put the first one.
Right. Because it'll have to be, your left bound would be up here for this one, but your left bound would have been down here for this one.
Yeah.
So what are the two, like, when I'm doing the two different ones, where will all the points be? So, like, one of them's gonna be up above the x-axis, and then...
There's always going to be one above and one below. So
Okay.
the one on the left, well, I hesitate saying it this way, but in this case, the one on the left is going to be, the above point is going to be your left, and the below point is going to be your right. And then the one on the right is, below is left, above is right.
And do I do them on different sides, like, of the y? Like, so it'll be like this, or would it be like...
We only care about the x. We're only looking for where it's crossing the x. So I could have done it way down here where I couldn't see it, and then way up here where I can't see it, and it'll still give me this point.
Okay.
As long as I did left and right.
Do they have to be above?
And it'll tell you there's an error if it didn't do it right.
Does it have to be above the x-axis, or can it be on it?
It needs to be a little bit above it. Because otherwise it may not, if it's not at least a little bit above it, it's not going to register it as being a 0. Because zeros are where the graph crosses the x-axis. So I don't care about anything else.
Yeah.
Basically, this is just a way of essentially finding your zeros without having to do a ton of work. Some people think this is harder. Some people think it's easier. The nice thing about it, what I will say, is that let's say you struggle to complete the square, because that tends to be, it probably wasn't honestly until I started teaching it, or at least in college, so I really understood what completing the square was. Let's say you're like, I don't think I completed the square right. This doesn't look right. You can always put it in because you're completing the square value. If you typed in, where is it? If you typed in this to your calculator, like -5 plus the square root of 61, and then divided it by 2, and then you did the minus 1, that should occur exactly where this crosses. So your values should be the same, and if they're not, and let's say you can't figure out what's wrong with your completing the square, you could say, I checked it by using the graphing method, and my numbers aren't the same, so I'm pretty sure something's wrong, and that's something.
So
I would use this more to check,
Yeah.
typically.
I don't know if I'm just doing something in my calculator wrong or what's going on, but I'm only getting 1.3 repeating. I'm not getting the -5 at all.
So my guess is you're not bringing your left all the way up here.
Okay.
Because if it's not somewhere up above the axis on this side, it's not going to for your left. And then your right will be down at the bottom. And you can't decide which one you're going to do first. It tells you have to do left first every time.
Yeah.
don't let me forget. I have your quizzes to get back to you too. Man down. Didn't do it?
Nope. May I try it, Lindsay?
Every single time I try, so
May I also see it?
I gotta get back.
My follow-up question would be, does your graph look like this?
Yes.
Okay.
How do I have Josh
Well, I wanna see what she's doing.
Okay.
in the second trade?
Yeah. It's in doing everything. In one time, so I don't know. And so, and then I go down. And I go
Right, no, don't go back around. He was supposed to go under there.
There's
Because you
the-
go like, wait,
As long as it's below the X.
side,
it's
you
good.
go like right there.
That's what I'm doing wrong. I'm going to the complete other side.
And for that side, go to the,
Okay.
that's what I was thinking first.
So it,
Silly, right?
so the right bound just has to stay under the x-axis.
Yes.
Okay. So,
For the,
and now I've got -5.
for some of us, try these.
All right, so these are your problems. You will have tomorrow in class to do them as well, because this is obviously a longer section. 17 is the other completing the square one that was like 18, but it can actually be done. 20, no. 24 is kind of a weird quadratic formula problem, but you just have to get everything moved to one side to do it. 47 and 51 are solve using any method, so you can pick whatever method would work to solve it. So if you want to do it by graphing, if you want to do it by completing the square, you want to do it by quadratic formula, or if it happens to work by factoring, you can pick whichever one you want to do. Just keep in mind, like with completing the square, if you were to choose that, you've got to be able to have that 1 in front, or you're going to have to do the dividing, which would never be my first pick if it doesn't force me to do that.
Yeah.